One of the earliest power stations in London was in Charterhouse Street, on the fringe of Smithfield, London's meat market. Although minute by today's standards, it was built in the grand style of the Victorians, solid, with decorative embellishments. It was fueled by coal. In time, the power station belonging to a Smithfield electricity supply company became redundant. But the building alongside London's famous meat market found a new role. It became a cold store. More recently, a fire engulfed the building. It burned for 8 days and 8 nights. But afterwards, the shell of the stricken building stood firm, a fine tribute to its constructors some 100 years earlier. That might have been the end of the story, but like the phoenix rising from the ashes, a new and perhaps surprising use was found for the building. It once again became a power station. Not just a power station, but a sophisticated, environmentally friendly energy center, bristling with complex high technology. The very latest in CHP, combined heat and power. The technique of combined heat and power is well established in Europe. The heat, which is produced as electricity, is generated, is captured, recycled and used to provide hot water for community heating and chilled water for air conditioning. It is an outstandingly efficient system. What's more, it's highly cost-effective, and there are substantial environmental benefits too. The Corporation of the City of London has a long and enviable track record for environmental concern and energy efficiency. The devastating smog of the 1950s led the corporation to declare the city a smoke-free zone, long before the Clean Air Act was introduced by Parliament. It was in this tradition that the corporation looked at the possibility of providing a CHP plant for the Barbican complex of quality high-rise apartments, commercial premises, and the famous Barbican Concert Hall. The close proximity of the buildings in this massive complex made it perfect for what was then considered a traditional CHP scheme. But among the submissions considered by the corporation's consultants was one that took the concept of CHP into a totally new dimension. The Citigen plan was for a total energy centre, which would be able to service buildings over the whole of the City of London, spilling over into neighbouring areas of Islington and Holborn. It was imaginative, it was innovative.
It would be a first time for a city centre such as the City of London, a business centre, although there have been CHP projects in the past in the country which have largely looked at large housing projects and the like, and even some from waste heat. But we felt that there was scope here because of the big city usage, and that for ourselves there could be major savings in future costs of plant and in future energy savings. And as well, of course, you've got the side benefit of a reduction in emissions into the atmosphere. CHP plants are very much more efficient in themselves in operation than individual plants. Working at higher temperatures, you get better output, lower emissions and lower costs.
CHP has only really taken off in the UK in the last few years. Previously, the UK had its own indigenous supplies of fuel, and so it had no real need for making a more efficient way of producing electricity. The continent, of course, have used this for many years because they had to import their supplies. What has happened in the UK now is that we're part of a changing fuel market. CHP is far more efficient. Up to 90% efficiency can be achieved, compared with 30 to 40% for the traditional methods of producing electricity. The other factor, of course, is the environmental concerns that the emissions levels are now looked at very closely with CHP, particularly with catalytic converters, as we have here in this plant, makes it a very clean option and certainly preferable to the traditional methods.
The noxious fumes, ash and dust expelled from the plant are subjected to state-of-the-art filtering and scrubbing. And finally, when the air emerges, it surpasses all European standards. It is actually considerably cleaner than the air below at street level. The environmental benefits of CHP are indeed very powerful. The dramatic reduction of NOx, or noxious oxides, of carbon dioxide and of sulfur dioxide, lessens the perils of smog, global warming, and acid rain. An indirect environmental benefit is in the provision of cool water for air conditioning. Conventional units in most buildings depend on the use of CFCs, or chlorofluorocarbons, a major contributor to the degradation of the ozone layer. Here, waste heat from the generators is gathered and fed to an absorption chilling unit, which provides the chilled water pumped to customers' premises. The first choice of fuel is natural gas taken from British Gas's distribution system. Probably more gas is registered by this meter than any other in London. On a cold winter's day, in excess of 160,000 cubic meters of gas could be registered to generate the plant's current capacity of 32 megawatts of electricity. Security of supply to customers is a prerequisite of the CHP plant. And for that reason, the engines are designed to operate on oil as well as gas. And there's a 1 million litre standby tank of oil, just in case. In the unlikely event that supply breaks down altogether, Citigen is able to take electricity from the local supply. And if there's any spare capacity, it can be fed into the electricity company's distribution system. Citigen uses its own dedicated cable and pipework to supply customers. The cable exit from Charterhouse Street is the one used by those pioneering electricians 100 years ago. It was inevitable that some roads had to be trenched to accommodate cable and pipework. For the most part, the existing network of tunnels and ducts under London's roads are utilised to distribute services to customers' buildings. But the problems of planning and installing the distribution system were nothing compared to the formidable problem of constructing and installing the energy centre in the two redundant Charterhouse Street buildings.
Both the buildings are very old. One of them is a listed building and the other one's a protected building, which means that you can't do too much to the facade or alter it too much in any way at all. The protected building is the old Port of London cold store that was built in 1914 for the New Zealand lamb trade. The listed building is an older building. It was built in 1894 and it was built as a coal-fired power station. When we took it over, just the facade was still in a usable condition. The rest of the building was in a very bad condition. And we undertook, as part of our responsibility, to restore it to its full Victorian splendour. For example, the chimney we've created above the building is a replica of the 1894 chimney and looks exactly like the original, although it's made of fiberglass.
Although the restoration of the exterior of the buildings was not particularly difficult, more a case of care and attention to detail, delivering and fitting the two 200-ton engines 3 stories below ground level presented some interesting logistical problems. First, the engines had to be transported from Tilbury docks. They became the heaviest ever loads to be transported through the streets of London. So heavy that bridges had to have temporary reinforcements, as did the roofs of underground garages. And planning the 50-mile route had to be meticulous. Potential hazards were identified and appropriate plans made to overcome them. Speed was irrelevant. The convoy crept along at a tortuous 6 miles an hour. On arrival, they had to be transferred from the road transporter to 3 specialist computer-controlled vehicles, which took them on their short but critical final journey. At times, there was barely an inch or two to spare, as each engine was maneuvered into position. One man controlled the operation. With an eagle eye and the delicate touch of a surgeon, the enormous unit was slowly, surely, gently eased into position. The throb of the V18 engines and the whine from generators were considerable potential problems in terms of both noise and vibration. The plant is surrounded largely by business neighbours, including Smithfield Market. The engineer also had to consider that within yards of the rear wall is the Thameslink Railway and the Metropolitan Line, the oldest part of London's underground rail system, as well as the fact that plans for the projected London Crosslink Railway showed that it would pass immediately under the building. The solution became an integral part of the total design concept. It was decided to locate each of the engines and generators on an inertia block, 1,000 tons of solid concrete. In all, more than 2,000 tons of equipment and concrete are sitting on a 30-millimeter high cushion, provided by 196 bags of compressed air. The new internal walls and floors are also of reinforced concrete and are anchored by rubber mount to the existing external Victorian walls. So when the engines are running full out, no one passing outside would suspect a thing. Citigen developed its own software to control the Charterhouse scheme, the largest CHP unit in Britain. The simplicity of the controls console belies its sophistication. Every stage of every operation is meticulously monitored. From the quality of the exhaust emission to that of the incoming gas. Of the water coming from the plant's own well to that being pumped out to customers' premises. Connecting existing buildings to the network is not at all difficult, where the heating system is based on hot water using radiators, convectors, or heater batteries. The only change is the substitution of a simple service station to replace the redundant boiler room. Where they exist, the cost of maintaining and servicing boilers, chimneys, cooling towers, refrigeration plant, and the additional costs of fuel storage are virtually eliminated. The impact of providing CHP services in a brand new building are very considerable, both in terms of capital costs and space. In one fell swoop, the architect can eliminate the plant floor from his plans. Into the foreseeable future, the current installation will be able to cope with all anticipated demand from both existing and new customers. But when that starts to reach a peak, there's space enough to substantially increase output.
Combined heat and power really does make sense. At a time when environmental issues are at the forefront of public concern and debate, CHP wields a very powerful argument for reassessing our traditional approach to producing electricity, hot water and chilled water. The reduction in the emission of harmful products alone provides a compelling case. Add to that the reduced maintenance costs, the lower running costs and the greater security of supply. It is our view that CHP provides the way forward for the future.
Citigen's citywide CHP really does make sense. Security of supply is far greater. It saves space. Maintenance is reduced. And it's highly cost efficient. Fuel efficient too. And using less fuel means lower emissions. Citywide CHP is ozone friendly. And with a highly effective treatment of flue gases, the plant makes a very positive contribution to making our cities cleaner and healthier. CHP and Citigen, generating for the new generation.